Okay, good evening. Welcome to
Math for Kids number 124.
124. Awesome. Blah, bonk. Today we're going to learn about the angles in a triangle. Okay. So yesterday we learned that if you go all the way around a circle, how many degrees do you have?
You have 360.
360. And then we learned that if you have a straight line and that's an angle, how many degrees are in a straight line? 180, because it goes halfway around. And we didn't do a video about this, but this morning when we were studying and learning about geometry, we learned that if you have two intersecting lines, if this angle is x, what's the other angle that's x? And if this angle is y, what's the other angle that's y? Okay, that's good. And what can you tell me about x and y? Can you tell me anything about x and y in this diagram?
Well, x plus y is 180.
Why is that?
Because this is a straight line.
That's a straight line right there.
And so is this.
Okay, and so the angles x and y have to add up to 180 this way, and they have to add up to 180 that way. So that's pretty neat. Now we're going to learn a fun fact about triangles. Actually, before we do that, I have to do one more thing. If the lines don't intersect, we have an interesting situation. So we have two lines. Do you know what it's called when two lines always are the same distance away from each other and you can draw them all the way to infinity and they never intersect? You ever heard this word before that talks about these lines?
No.
It's called parallel. You heard that word before?
Yeah.
Yeah. Okay. So these lines are called parallel. Now, if I put a line right across two parallel lines, we know from what we just talked about, actually, let me see if I can draw it in purple, that this is x, and this is x, and this is y, and this is y. Think you can say anything else about some other angles in this picture?
Well, are these the same? The x's and y's?
Well, but are they all? This is definitely A and B and B. But do you think there's any relation between the A's and the B's and the X's and the Y's if these lines are parallel?
They're the same.
What's the same? What do you think is this?
A, B, X, and Y.
So what do you think is the same as X?
A.
And what about the same as Y?
B.
B. Okay, that turns out to be right. Why do you think they're the same?
Because the lines are the same.
Because the lines are the same? What does that mean?
Means that if you draw through them, you get the same thing.
Okay, so let's try to understand. Because these lines are parallel, one way to do this, it would be to imagine that you took this line and you just moved it down to this line. Then the angles they'd be right on top of each other, right?
Yeah.
And so there they would definitely be the same. And so if you just pick it up and move it away a little bit parallel, so you're moving all the points the same distance away, you're going to keep the angles the same. Now that doesn't tell you for absolutely sure that that's right, but that's trying to give you a good idea of why that's true. Now we have enough to talk about triangles. Okay? So triangles have a really interesting property. Whoops. I guess I'll use my purple marker. Let's say I have a triangle like this, and I'll call this A, B, and C. And triangles have three angles, and we'll call this angle B, this angle C, and that angle A. Okay? Now there's a really interesting situation here. If I draw a line parallel to this side of the triangle up here, something really amazing happens. Let me extend that line that way and that line that way. Remember if we called this X, because this blue line is parallel to this purple line?
Yeah.
This angle up here was X. Does that make sense?
Yeah.
The angle between the purple line and the blue line, I mean, like this. Okay?
Okay.
And then what other angle is x up here then? Can you see? Can you see what other angle is going to be equal to x?
This.
Remember, it's the angle that's going to be opposite. It's going to be opposite the intersection of, can you give me the blue pen? It's going to be opposite the intersection of the blue line and the purple line. So where is the x? Draw it in.
Here.
Draw it in. Go ahead. So an amazing thing happens. So when I have a parallel line, I know this angle is x. And then by our reflection property, this angle is x. Now, let's call this angle here y. I don't know why I called them A, B, and C, and now I'm calling them x, y. But I don't know. Sorry about that. What angle is equal to y up here with this parallel line? Do you see where there's another angle equal to y that makes the same angle as this going up here? Y here. And then what's the other y?
This y.
This y. And this angle here, we already said was equal to A. Remember when I first said they were all A, B, and C? Remember that? So look at this. What can you tell me about x, y, and A now, since they're on a straight line?
Why is that marker not
I can't seem to hang on to the markers. What can you tell me about x, y, and A on this straight line here?
Well, they add up to 180.
They add up to 180. So look at this. X plus y plus A equals 180 degrees. But what were x, y, and A right at the beginning? They're the angles of the triangle. So can you believe that? We just showed that the angles of a triangle add up to 180 degrees. Isn't that interesting?
Yeah.
So what if I have a really special triangle where all the angles are the same? That's called an equilateral triangle. All the angles are the same in this triangle. If all the angles are the same, what are they? Remember, they add up to 180.
Well, they're all x.
They're all x.
So
what equation do we have?
x times 3 is 180.
3x equals 180.
X equals 180 divided by 3.
Yeah, what is 180 divided by 3?
Which is 60.
60, right. Good job. So if a triangle has equal angles, all the angles are equal to 60 degrees. And that's a special kind of triangle called an equilateral triangle. Pretty neat, right?
Yeah.
So you just learned a really fun fact tonight. That no matter what triangle you draw, the angles of that triangle add up to 180 degrees. That's pretty cool. So the angles in a triangle add up to the same as a straight line. Who would have thought that?
Whoa.
All right, good job tonight, honey. We'll study a little bit more geometry tomorrow.